do something to make sure you keep them. Okay, so let's focus. So today we're going to add vectors by scale. These are any vectors that are at any angle. I don't know how many times I've had to write on a test, not a right triangle. And I was showing the band girls yesterday. More than once, I've seen an angle like this, or a triangle like this. People draw R, it's nice, it's pretty, it's good, and then they write R squared equals some numbers squared. What's wrong with that? Not a right angle, not a right triangle. You can't do it. If you want to get me angry, do that. Drives me nuts, because I spend so much time exaggerating and playing the fool up here, and obviously I'm not reaching everyone. So maybe this is the class. This will be the year that I don't have to write it on any test. Can you do that for me? Yeah. Not a right triangle. Okay? You can only use Pythagoras when the vectors are perpendicular to each other, 90 degrees. How do you know? Like if it's like south and east or north and west. Right? I guess it couldn't really be north and south, could it? Okay, so make sure you know the difference between a right triangle and a non-right triangle. Easy, easy marks, you guys. You're throwing them away. Vectors that are not perpendicular must be added by using scale diagrams. It says it right there. You can't say I didn't teach it to you. I'm not a very good highlighter. The resultant is then found by ruler or protractor. In grade 12, I'll give you a mathematical tool to do it. Those of you that have completed grade 11 math, or maybe actually you're just in it, will likely know that you could use what? Sine law and cosine law. It is possible. It's a little messy. It's an okay application of it. I find, physics teachers find that it's better for future knowledge to understand and be able to do it by scale drawing. Okay, it's a little bit more hands-on, a little bit more intuitive. So even though you can use sine law or cosine law, I really want it by scale drawing for now. Does this introduce some error? Some measurement error, Will? Absolutely. What are the rules that I gave you yesterday? Plus or minus? 3 millimeters, plus or minus, plus or minus 3 degrees, which is a huge range. It's plenty big enough. If you are more than plus or minus 3, you're not doing it right. Okay, so you've been taught how to draw scale diagrams. You've been taught how to add vectors. What's the rule? How you arrange them? Tip to tail. We've done the pirate thing, which is really what this is. So this, you already really know how to do this. I'm just formalizing it, really, right? Should I do this one, or should I let's try? Let's try? No? Do it. I'll meet you halfway. I'll leave you about a minute and a half. Give me enough time to do attendance, and then I'll do it. If you want to start, you can. Let me show you a few tricks. Now, I actually have to, give me a second here. I got to pull my ruler and my protractor out. It's considerably more challenging for me to do it up here than it is for you guys to do it on a piece of paper. But I've practiced, so. Do you like the 360-degree protractors? No? I see some of the people using them. I found one yesterday that was cut in half, so obviously they didn't like it. That's okay. Some people don't like them. Let's have a look. Okay. I find that when you're doing these, it's a good idea to draw a little sketch in the margin, sort of an idea of where you're going, okay? There are some of you out there that are big on saving paper. I get it. You can't save paper when you're doing vectors, okay? Stop trying to scrunch things in. Okay? I gave you plenty of space for a reason. Having said that, there is a limit to how far you can go, right? So you do need to sort of be aware. Let's have a look at it. 10 kilometers, north, 30 east. So right away, I'm going, which direction? North, 30 east. So I'm kind of going like, I'm kind of going like that, right? And then west, 15 north. So then I'm going to kind of go like this, right? So that's kind of a rough sketch. Where should I start? Should I start in the top left-hand corner? No, obviously not. You're going to run out of paper right away. Where do you need to start? Way down in the bottom, actually, right? The middle, you might still run out of room. So you got to sort of plan that out a little bit. Okay, so we're going north 30 east. Now, this is one thing that I'm going to require. I want what I call a reference line. If you want to do this, some people like drawing the crosshairs, north, east, south, west, right? That's okay. It tends to be a little bit too much for my liking, but if it works for you, you go ahead. All I'm requiring is that you have a reference line, okay, that defines what north is, so that when I get my protractor, I can follow your footsteps, kind of thing. Okay, so it doesn't need to be long, it just needs to be there. So that's north 30 east. Oh, and I started in a bad spot, didn't I? Because I need to go up and to the right. So fortunately, I can do this. Fortunately, you guys are all using pencil, right? Who's the 2 or 3 people that insist on using pen in the room? Because there's always some. I shake my fist at you. North 30 east. Okay, so we're going to bring in our protractor. And I'm going to set it on here for north. Right? North is at 0. Now I'm going to put a little tick mark at 30 degrees right there. Right? And north 30 east, now it's 10 kilometers. Now the other thing I haven't done is I haven't written down my scale. Okay, here's another one of the things that drives me absolutely nuts. It's 1 centimeter equals. You always start every single scale with 1 centimeter equals. You could go 1 millimeter if you want, but it's really not enough. Okay? It is not, Josh. 10 or 1 kilometer equals 1 centimeter. It is 1 centimeter. Whatever is first means what's on the paper. It is always 1 centimeter. Always. In this case here, I got 10 kilometers and 8. So I'm going to probably put 1 centimeter equals 1 kilometer. That's important. It's part of the solution. I'm going to mark that. 1 centimeter equals 1 kilometer. Now, I'm going 10 kilometers, so I'm going to go 10 centimeters. So bring in your ruler. Now, you can see here how much trouble I have with this. Now, here's a common mistake. I measured my protractor from the bottom of the line, right? That's where I put it. I think I did, anyways. Or did I? Yes, I did. Okay, so I got to put my ruler right there. I get some people that want to start from there. That's wrong. Okay, there's your reference line. And I got to line it up with, see how hard it is for me? That's pretty close. And I got to go 10 centimeters long, right? Put an arrowhead there so I can see what direction you think it's going. It's important. The old applied math exam, it was a half mark off if you didn't put an arrowhead on. Put an arrowhead on. Okay. Everybody with me so far? Everybody good? This is the reference line. This is the line that shows north. And where's the 30 degrees? That angle there is 30 degrees, right? Everybody good? Now, ideally, you should probably do another reference line. You really should. I'm a little bit lenient on this one, but you got to have one to start with, so I can at least get started. So the next one is west 15 north. So really, you should put your protractor on, okay? And you should make a little reference line right there that shows west. Ideally, really what you should do is put your protractor like this, line it up so that it's at 30, right? And then mark a little thing here, so that's west. Like, if you take care, you can get pretty accurate, okay? I understand, okay, whatever. You should really have the line marked west. It's easy for me because the computer goes straight sideways. Not so easy for you, right? So that's my reference line for the second vector, which is west 15 north. West 15 right there. It's 8 kilometers, so I need 8 centimeters. Okay? A sharp pencil is pretty important. I won't say it's critical or crucial, but it sure makes it a lot easier. Right? A sharp pencil. Does that sort of match my original sketch? It does. What's the next step? Andrew, what's the next thing? Don't know? What did we do yesterday? Once we got our 2 vectors, what do we do? Draw the resultant. Where does it start? Where you started. I'm going to do it in a different color, or I'm going to do mine dash because it's easy. Where you start to where you, oh, I didn't even get started there very good. Where you start to where you end. Okay, like that. It's a great idea. It helps me a lot. If you mark that as R, you mark this one as 10 kilometers. If you label them, then I can see what I can sort of figure out your thought process. It helps me with our marking. If you make a mistake, but I still see them labeled, I can figure out what you're doing, and I'll lock you some part marks. Okay, so it's important. Alex, what do I do next? I got my resultant drawn. What do I do? How do I figure it out? 10 squared plus 8 squared? No! Not a right triangle. How do I figure it out? I take my ruler and I actually measure. Oh no. I get about 11.2. 11.2 centimeters, which equates to, I guess, 11.2 kilometers. You don't need to yell at, I got 11.1, I got 11.4. What's the rule? Plus or minus 3, which means your answer could be anywhere between 10.9 and 11.5. Now, actually, I've got it figured out mathematically, so I know the absolute, true, correct answer. What is the absolute? I don't know. I mean, I've got all, when I'm doing a test, I mean, what I'm saying is when I'm doing a test, I've got it figured out, right? So that's where my plus, this is my rough measurement version, right? So as long as you're reasonably close, it's good. Okay, are we done? Tell me, am I done? Really?
Nope.
Are you sure? Yeah, you don't know. I'm missing one thing. What is it? I'm missing the angle. Good for you. Now, here's a common mistake that people always do. This one doesn't drive me as nuts. Here's a common mistake. They want to measure the angle between the 2 vectors. They want to measure this angle. Wrong. You measure from the reference line, which is why you draw it. Okay? Because all of these are like north 30 east. If I measure this angle, that's 45 degrees. Well, how am I going to say it? Is it going to say 45 degrees to the west from the first one? Because that's what it is. That sounds great. Okay? You have to measure from the reference line. So I'm going to put my protractor straight up and down on that. Oh, jeez. Going to put it straight up and down on that reference line, like so. And I see that my angle is about 14 degrees. Okay? From north, 14 degrees, right there. Okay? So it would be 11.2 kilometers. What's my direction? North. 14 west. North. 14 to the west. Austin, am I done now? Yes, I am. What kind of answer do you get, Brody?
Like the resultant, I got like just under 7 centimeters.
Oh.
And for this one, I'm getting like 9.
This is nice. This is 33. So you're supposed to be north 30, right? You went east and then 30. No, north. Yeah, but it's north. See, it's north 30. You look north, and then you go 10, 20, 30. So it's there. Okay. So like in that case, if you did this one, right, which it looks like you did, you'd probably get either 2 or 2.5 tons. Okay? Yours looks like that? Got some arrowheads on there? Good? Andrew, yeah? Yeah, get a pencil, man. I guarantee you're going to need a pencil because you will make mistakes. Okay, let's flip that over. Let's have a look. The next one. I'm counting down. I'm just going to get people started on the next one. Okay, so that's a straightforward one. Go ahead, try this one here. Scale's a little bit different. Now that you've seen one, try it. If we have to fix it, we'll fix it. Try it. Okay, I'm coming. You guys are asking good questions out there. This is good. 80 kilometers. Andrew asked, does it matter that it's kilometers per hour? And the answer is no. It's just a unit. Don't freak out. You don't just change it to kilometers because we're talking distance. I'm going to use a scale of, again, 1 centimeter equals, some of you went 1 millimeter, I'm okay with that, but it must be that unit first. 1 centimeter equals 10 kilometers per hour. Could you have gone 5? Sure. South 40 east. South 40 east. And then east 75 north. East 75 north. This one's shorter. So roughly like that, right? Okay. Draw a reference line south. Again, it's easy for me because mine automatically puts it straight. You just draw the line and say, that's south. I define that as south. Okay. Now, I saw a couple of people that were doing measuring from... Oh, no. Okay. Measure from here. South, right? Yeah. Okay. Measure from this end here. Okay, don't put it like this. Put it from here. That line's marking south. Go to the tip of that line. Okay, and I'm going 40 degrees east. So 10, 20, 30, 40 degrees to the east. I'm using the technology available. 40 degrees. And now I need a ruler. Can you see how you can, it's easy to make a lot of any mistakes here? 80 kilometers, so I got to go 8, right? From there, from the tip, from the north end, and I'm going to go, oh, geez. Okay, 10 centimeters, right? I'm going to go all the way to 10. 8. Easy mistake to make. Use a pencil. Okay. I thought most people got that right. Then again, a reference line. East 75 north. You need a line that goes straight east. Okay, just only needs to be about a centimeter long, just long enough so that I know what you're saying is east. Then I'm going 75 to the north. So from east, and I'm going to go, Josh, 75 north, right? Okay, and I'm going 35 kilometers an hour, so that's going to be 3.5. Josh, I sense a move in your future. New postal code. 35 kilometers an hour is going to be 3.5. To there. Okay? Where do I draw the resultant from? Where I started to where I end. Okay? And now I measure. I do not use Pythagoras. It's not a right triangle. I'm going to say 6.7.
I got 6.6.
Again, plus or minus 3. 6.7 centimeters, so that's going to be equivalent to 67 kilometers per hour. Put the proper units. Okay, put the proper units. And then, where's my angle? Now again, don't measure from the other vector. Measure from your original reference line. You've already got it there. Use it. So from south, it's going to be 65, right? So that's going to be south, 65 east. How do you feel about this? Easy marks on the test, right? Easy marks. Actually, good question. Real soon. Probably end of next week. I'll do a little outline on Monday, especially when everyone's back.
So what else?
Like I'm thinking, there's all I gotta do is do some word problem stuff, really. Like, could easily be Thursday. Maybe even Wednesday, actually. I'm thinking of it. For sure next week. Okay. There are, I believe, can I see yours now? There are a couple more practice ones on the bottom. If you want, you can use those. There's probably not enough room for both there. I don't know. Okay, you might have to overlap. So there's some practice ones there if you want. I also have. I have some practice ones here with solutions, and I have a hand in. And what I think I'm going to do is I'm just going to give you both, and I'm going to say when you're ready to do this, when you feel like you know it as well as you can, hand it in. But I need this before the test. You're not writing the test till this is in. So give this one out first.